The question 5 is about asymptotes and we are using limits to solve them up. There are three types of asymptotes: vertical, horizontal, and then other one is oblique or slant. If you recall in grade 11, we were struggling to solve these horizontal asymptotes with rules. If the degree was 1 and this is greater than y is 0 and all that, different rules were there. Now you can ignore all the rules, we can just use limits and solve them up. First thing, vertical asymptote is the the vertical line where graph cannot be over here, whereas horizontal asymptote is horizontal line. So the graph will never touch this, but it will go very close to these points, but it will never touch. That is about the asymptotes. Now, how do we find the vertical asymptotes? It's very simple. Whatever is down in the denominator, we just make it equal to 0. Now, this numerator is x, right? So it's much easier to solve such problems. Just whatever is down, make it equal to 0. Let's solve it up. Here we go, mod 5 and 3. That is quadratic because it's power 2. Now, what do we input? Let's write this power 2 first. It's minus x power 2. What is the x term? See, this is x power 2 term, then this is x, and this is the constant term. Do we have any x term? No, that means it's 0x. And then we have plus 4, that is all equal to 0. So we just type in the coefficients. If there's nothing before the x squared term, it's 1. But we have minus, and there's nothing, so it's 1. And then we have 0, that means the x term is itself not there. Here x term is there, x squared is there, but nothing, no number. That's why it's 1. But as this x term is not there, it's 0, and lastly 4. So what is the answer? It's 2 and minus 2. So the horizontal asymptotes would be, sorry, this is the vertical asymptotes. I'm talking about vertical asymptotes would be x plus or minus 2. Or you can write x plus 2 and minus 2. Now, what about the horizontal one? Horizontal is the horizontal line. Okay, this one, horizontal. Here, it's very simple. We just do the same equation. See the same equation, 4 minus x squared. We take the limit of this at x is infinity and the limit of this at x of minus infinity. Same given function. Okay, it's 4 minus x squared. Now, what happens here? If we go towards positive infinity, that means we are going towards plus infinity here along the x-axis, right? So here this becomes, you just substitute infinity and you'll get, but not infinity, a big number, that's it. Whereas we go towards the minus infinity, we will come to know what's happening in the left side. So if there's a single line, then we can tell this is the horizontal asymptote. So basically, because the asymptotes end conditions, if we take x of infinity, if we take the limit, we'll understand what happens to the graph at the corners, right? So the same thing we are going to do now. Let's go to computation mode, and here we will type the given equation, that is x, that is alpha x over here, divided by 4 minus x squared. Then calculate it at what? Infinity and minus infinity. So infinity is a big number. Okay, now we can see it is minus 1.00. What does this 10 to the power minus 5 mean? This tells it is 0. This is minus, sorry, 0.0001. No, there's one more 0 and then 1. And then again 0. So it is a very small number. Let us calculate it at minus infinity. I'll just put some more 9s. And you can see it's such a small number. It is 9 zeros and then you have 1. So it's almost equivalent to 0. Can you see that? It's almost 0 because it's 1. You can see it. It's 1 into 10 to the power minus 10. It's such a small minute number. So we can directly say from this, y, the horizontal asymptote y will be equal to 0. That's the answer. Horizontal asymptote is 0. Vertical asymptote is plus or minus 2. Let's look over here. You can see here it's plus or minus 2 and 0. Because it's in the electronic part, directly do it in calculator. That's it. Now, denominator is same as the previous, only the numerator has changed. So let's do the limits. Here x squared. Calculate at, say, minus infinity. What is the answer? It's negative 1. Calculate at positive infinity, 999. And it's minus 1 itself. So again, we have easy, same answers. The vertical asymptote is plus or minus 2, whereas the horizontal asymptote is at minus 1. We got it. Now, if you had got two numbers at left side and right side, then there are two horizontal asymptotes. You will see such problem. I think so over here it's square root. You might have two horizontal asymptotes. So first thing is whatever is in the denominator, right? Mod 5 and 3. Now when I look over here, I realize there is an imaginary number. So now in such cases, square root, don't be worried. This is equal to 0. Square both the sides, it will be 4 plus x square and you will have 0 itself. So now we can put this in the calculator. It will be x square plus 0x plus 4. So here a value is x square, that is 1, 0, 4. The values are imaginary numbers because over here it's positive. When it goes to the other side it becomes minus. Square root of minus is not there basically, right? Looking at this only, whenever you have square plus another term and you have to equate this to 0, it's imaginary, it's not real numbers. So here there is no horizontal asymptote or vertical asymptote at all. We are doing vertical, denominator is vertical, there is none. What about the horizontal asymptote? Let's try. Here, let's go back to the computation mode. Let's put this fraction x divided by square root 4 plus x squared. Is that okay? Now calculate it at infinity. It's at 1. Calculate it at minus infinity. Now you can see it's minus 1. There are two horizontal asymptotes. There are no vertical asymptotes. See, we don't have. There is no. X is never 0, so there is no vertical asymptotes. But for horizontal asymptote, we got y is 1 and y is minus 1. Two are there. How do we solve this? It's just the same over here. It's just plus. You will have vertical and horizontal in this case. See here, there is vertical asymptote because if you put this minus 1, 0 and 4 to the in the calculator, I'll show you over here. Just go mod phi 3 and put in the coefficient minus 1 because minus x squared is minus 1. Then there's no x term, 0 and 4 is the last term. Here you get 2 and minus 2. So these are the vertical asymptotes. Now what about horizontal asymptotes? Let's try. Here we will just go back to the computation mode and then fractions x divided by square root 4 minus x squared. Calculate this at minus infinity, that is error. Then let's calculate it at infinity, 999. That's also an error, right? So in this case, what do we know? We know that there is no horizontal asymptote because both the sides there are errors. I hope this is clear. Now let's go to the next one. Now here you can see the numerators before were just x. It was very easy, but here we have to be careful. Why? Because we will do this mod phi 3 denominator. It's 1, minus 2 and lastly minus 3, right? What are the x values? 3 and minus 1. These are very important numbers. 3, minus 1. Now what you need to do is you need to put these in the numerator and check. So the easier method would be just type whatever is the numerator, 3x squared plus 1. Okay, and calculate at 3. What is the value? It's 28, it's fine. It should not be it should not be 0. That's the only thing. If you put over here, yes, that's fine. Now, what about calculating at minus 1? It's 4. Is any of this 0? No. So we just consider both these vertical asymptotes. And how do we do the horizontal asymptotes? We type this entirely 3x squared plus 1 divided by x squared minus 2x minus 3. Now here calculated at infinity, it's at 3 and calculated at minus infinity as well, it's at 3. So you can see here y value is 3. We got 3, right? Both the cases. So that's the thing. And what about the vertical asymptotes? It's 3 and minus 1 both exist because there is no problem with the numerator. Okay. And then what about this one now? Let's do the same thing. I will first find the horizontal asymptote because it's already there. I'll just rearrange this. It's minus 2 and here what do we have? It's x plus x. And then we have x over here, 1 minus x. So I'll just remove all the other terms. Okay, calculated at minus infinity. What is the answer? It's 0 because it's minus 10 to the power minus 7. And calculate it at 999 positive infinity, it's again 0.00. It's almost 0. And 0 is neutral. Sign doesn't matter to 0. So it's very easy to find the horizontal asymptotes. But what about the vertical asymptote? Here, mod phi 3, let's put these in the coefficient. It's 1, 1, sorry, it's 1, 1, 2. So it's minus 2. All you do is see 1 and minus 2. Now here, minus 2 is fine. When you solve the about term, minus of minus 2, you'll get 3. That's absolutely fine. But let's put 1 here. 1 minus 1, what happens? It's 0. So this cannot be allowed. Your vertical asymptote, there are two vertical asymptotes, yes, 1 and minus 2. But when you put 1 up over here instead of x, it becomes 0, so it's not allowed. What do you need to consider? Only the other asymptote x is 2, and we had got the horizontal asymptote y was equal to 0, isn't it? So now here, sorry, is it 2? It's minus 2, my bad. We had got, this was the previous numbers, so we had got minus 2 and minus and 1 and minus 2. So we apply over here, we would get only minus 2 here as the answer. So horizontal asymptote over here is 0, vertical is minus 2. Let's just check the answer. It's minus 2 and 0. In this problem, we have trigonometric function and its inverse trigonometric function, tan inverse. Doesn't matter, it's just the same. But it really helps if you understand what is trigonometry function over your tan inverse. It's something like this. It has no vertical asymptotes. It keeps on going forever. So now you can see here, there is no divided by 0. So you can understand here there is no vertical asymptotes. And from tan inverse function also, there is no vertical asymptote. But what about the horizontal asymptote? Where does it end? Just take the limit to infinity and then minus infinity. So we will directly do it in the calculator. Let's type it out over here. Tan inverse, 4 tan inverse, that's shift and tan, alpha x, close the bracket, minus 1. Here, remember you have to press shift, mode and 4 if it's not already in radian. And then what you need to do is, if it is in degree, see shift mode 3 is in degree, you will have a d over here on the top. If you convert, let me keep it in degree and I'll show you the answer. Let's calculate it at infinity, say big number 999. You're getting 358.9, it's 359 degrees, but we want exactly in radians because the answers only will be in radians. So shift mode and 4. Now you can see the value is, if for infinity, that is 999. Let me write it over here. As 10x tends to infinity, you're getting 5.283. And what about minus infinity? Let us do calc minus 9999. And what is the answer here? Minus 7.28. So it's here x tends to minus infinity, minus 7.283. Now, what are these values? In your options, you won't have these decimals. See, I will show what will be options. You will have something like this. You will have 2 pi minus 1, 2 pi plus 5 pi, or something like that. You need to make sure, type all the options for the horizontal asymptote. See, 2 pi minus 1. This is from where? From towards positive infinity. And then press equal to, what is the value? Isn't it the same thing? Yes. And another answer was minus 2 pi minus 1. Can you see? They both match. So these are the two correct answers. All the others would be wrong answers. So that's how we come to the conclusion that these two are the answers from 2 pi minus 1 and minus 2 pi minus 1. They are the horizontal asymptotes and there were no vertical asymptotes. From here you can tell there's no vertical asymptotes. Now let's look at this function here, ln of 1 minus cos x. Now you should know some basic things of natural logarithmic function. Here, if you know this graph, this is the ln graph. Do we have any vertical asymptotes? Yes, at 0, right? When does it occur? Always for natural logarithm, whenever the natural logarithm is 0, there is a vertical asymptote. So ln over here, when it's 0, there are vertical asymptotes. But where is the horizontal asymptote? There are none. You can try You can try in your calculator making limits. You can see there is none. It goes to minus infinity till plus infinity. It keeps on going. Now, how do we find the vertical asymptotes? Here, whatever is there inside the brackets must be equal to 0. 1 minus cosine x is equal to 0. Let's solve it. 1 is equal to cosine x. Now here, let me write cosine x is equal to 1. In this case, you need to know what is cosine graph as well. Because whenever cosine x is 1, here, whenever cos graph is 1, that becomes 0 and it's undefined. There are all vertical asymptotes over there. So what is cosine graph? If you recall, it starts at 1, it will go like this, and then it'll come up and something like that, and even in the other side, right? So all these are 1 value. This should touch over here, and they are all 1. Whereas the lowest point is minus 1 in cosine graph. So here technically this is 1, this is 1, this is 1. So there are many ones. At when does it recur? When x value is 0, when x value is 2 pi, when x value is 4 pi, multiples of pi. So you can just tell it's multiple of 2 pi, not multiples of pi. Whenever we have minus 2 pi and so on. So if we remember, cosine graph will be 1 whenever it is multiples of 2 pi, or it will be 0 again, multiples of 2 pi, right? So what we do is x is equal to multiples of 2 pi, but there is every integer multiple, so we write k here. K in the sense k is an integer. K is an integer. You should write so much. That means whenever k is 0, 1, 2, 3, just substitute 0 means 0 pi, or 1 means 2 pi, 2 means 4 pi, 6 means 12 pi, and so on. It is undefined. You will have vertical asymptotes. That's the answer. And there are no horizontal asymptotes or slant asymptotes. We can check that in the calculator. See here, if you put ln 0, you get undefined. Why? Because it's an error. This is the natural logarithm graph, okay, ln x graph, not this one. I'll show this graph in a while. Now, one more important thing is testing for what? Testing whether there is horizontal asymptote or no. Let's put in the coefficient, the given question. It's 1 minus cosine x. Close the bracket for cosine and now close the bracket for natural logarithm. And let's do calc at some values. Here you're getting, let me just change the value. See, it's just varying. There is literally no asymptote, okay? It just varies. Now if you change it to minus infinity, you can see it just varies again. So there is only vertical asymptote. What is the vertical asymptote? See over here, x is equal to 2k pi, which we wrote over here, okay? Or k into 2 pi, it's the same thing. Now this is the graph of this particular function. You can see it's having at every 2 pi, that is pi is how much? 3.1. For 2 times it's 6.28. So you can see over here at every 6.28 interval you will have a vertical asymptote. Finally, we move to the last type of problem, that is the slant asymptotes, or it's also called as oblique asymptote. They occur only when the numerator is exactly 1 degree more than the denominator. See, this must be 1 more than the denominator. Now, how do we find this? This is only done by long division. Now, whenever you have single terms, it's very easy. I'll show you how. But whatever happens in the denominator, you have to write the highest degree first, minus x squared plus 4, like this. So you need to do long division. What is up? Now, if you had, say, 2 divided by 8, how do you do it? 2 is over here. So now, generally, you will be given like this. Okay, let's take 12. 12 will be over here, 8, and then you start dividing, right? Same way here, whatever is up is written inside, and what is down here in the standard form, minus x squared plus 4. All you focus here is, since this is single term, only one step, you don't need to do anything else. Just multiply with a number such that when I multiply this with that, it should be x power 3. So all I do is x power 3 divided by minus x squared. What is the answer? This cancels off, minus x, right? So I will write here minus x. Now let me multiply minus and minus, will be plus x to the power 2 times x, x is x cubed That's the answer. It changes its sign at 0, right? This is the answer over here, whatever is there. So this is the slant asymptote. Slant asymptote y is minus x for this particular problem. What about the vertical asymptote? Vertical asymptote is same. Whatever is down here, see this, whatever we wrote, make it equal to 0. And we have solved this before. X will be plus or minus 2. Mod phi 3, you will get the answer. So that's it. This is one answer and another answer. Whenever there is slant asymptote, there is no horizontal asymptote. Why? Because the numerator degree is more than the denominator. There is no horizontal asymptote, only slant asymptote. Also be careful, this difference must be exactly 1. Only then there is slant asymptote. So let's do the next one here. X squared plus 1 divided by x minus 2. What do we have to multiply here? X squared by x is just x. That's the thing. And then minus 2 times x. What is happening? Okay, here I will let you know one important thing. Whenever there are two terms, right, in the numerator, x squared, you have to write x term. Is there any x term? Not there, so it's 0x plus 1. So here I need to write 0x plus 1. Now, we multiplied x times x, you got x squared, then minus 2 times x will be minus 2x. You change the sign here, change the sign. If it is plus, it becomes minus, minus becomes plus. This cancels off. Now, solve it up. 0x plus 2x is how much? Just 2x. Now, how do you get 2x? When you multiply by what? By plus 2. So x times plus 2 is 2x. You don't need to do this. This is your answer. Here the answer is y is equal to x plus 2. This is the oblique or slant asymptote. What about the vertical asymptote? X will be equal to 2. That's it, because we have to make the denominator equal to 0. You can see here in the first one we have got minus x plus or minus 2. Here it is x plus 2, which we just now got, and x is 2. Now here there are two more problems. This one is easy because there is no x term or anything. Directly you can get the answer. But here, look here, x power 3, but there are full terms here. Let's start solving by long division. X power 3. Here you will have x power 2 plus x minus 4. Now what do you multiply it over here with? It's x. So x power 2 times x power 3 is x power 3. Then what next? Multiply this plus x squared minus 4x. That's the answer. Now it all changes, minus, minus and plus, and you cancel this off, and you're remaining with what exactly? A minus x squared minus 4x. Sorry, plus 4x. Now remember, this term exists. It's not directly the the number. Why? Because if there was no middle terms, you can just tell the answer. See over here, x cube and then directly the number, right? There is no x square or x term. So when you solve it up here, directly you can tell the answer is x, because it will be x power 3 plus 0, 0, 0. Sorry, x power 4 here. And then other thing will be just 2x. Now there will be zeros in the middle. Ignore that zeros. It will be 2x, right? When you solve it, this cancels. You will have minus 2x. Look here, the degree over here is more than the denominator. This is a remainder. You leave it as it is. But here, sadly, when you solve it up, this is 0, right? 0x squared. Nothing is there. This term comes down. It will be minus x squared. So we still have to solve, because this is the same degrees. That means we have to solve. How much do you have to multiply x squared to get minus x squared? It's minus 1. So x squared times minus 1 will be minus x squared. Then you don't need, because we are a number. Once you get the constant term, done. Because anymore, whenever you solve, the answer over here will be x, which will be less than this term. Done. So it's just long division. I'm not doing the entire long division. See, the entire long division is done before. But here I'm just trying to do the simple, just to get the answer. Simple ways just to get the answer. And these are the horizontal, slant asymptotes. Now what about the vertical asymptotes? You just put in the calculator. Let's take the calculator here. All you do is mod phi and 3. And this is 1, 1 and minus 4. What's the answer? It is minus 1 plus root 17 by 2, and then there's one more answer, minus. So it's plus and minus. That means there are two answers. One will be this answer, another one will be, with plus. So you can see it's with plus and with minus. They are two different values, but they'll write it in terms of fractions. Now, what about over here? You can just do the same thing, mod phi, but here it's power 3, so you can go with option number 4. What is the coefficient of x cubed? Let me get back the calculator. Here it's 1. What is x squared? There is no x squared term 0. This is x term 0, and lastly number is 2. So it's 1002. The answer is minus 1.25. And then look at this. This is imaginary. If you have something like that plus, that will be imaginary, imaginary. So which is the only correct answer? It's minus 1.2599. Now if you solve this up, let me go back. Minus cube root, shift and this root symbol here, 2 gives you the same answer. So that's it. So this is how we basically solve. And y was x over here, isn't it? Only over here we got x minus 1. So this is how we solve slant asymptotes. And that's the end of this question. It's a bit lengthy one, but just make sure you get the answers directly using calculator. The starting ones are very easy. Only for slant asymptote, you have to do long division method.